6. Discussion. Let's read the problem. The geometric sequences 162, 54, 18 and 2 by 81, 2 by 27, 2 by 9 have their nth term equal. Find the values of n. Pretty different, isn't it? Okay, anyway, let's mark. So what it means, it's a geometric sequence. There are two geometric sequences. One is this, the second one. And the nth term of this series is equal to the nth term of this series. They want to find the nth term. Anyway, so let's do for the first series. We have a equal to 162, t2 is 54. For the second series, a or the first term is 2 by 81 and the second term is 2 by 27. I'm not considering this because we are not asked to check whether it's a geometric sequence. We are only asked to, it's already given. So we don't use t by t3. Okay. Right. So let's list it out. So for the GP, for the geometric progression or sequence 162, 54, 8, a equal to 162, t2 equal to 54 and t3 equal to 18. This is not required. For GP 2 by 81, this sequence, a equal to 2 by 81, t2 equal to 2 by 27 and t3 equal to 2 by 9. Okay, so what are we asked to find? We are asked to find the value of n. And it's also given the nth term of this sequence equal to the nth term of this series. Okay, so that is also, that needs to be written. I missed it out. We'll make that correction next time. Okay, and we are asked to calculate the value of n. So what's the typical formula? Tn equal to a into r to the power of n minus 1. So you'll have to find, a here. You have to first find r. Then substitute those values and get the value of Tn. Okay. So then Tn you'll get in terms of n minus 1. Similarly, find that for the second series. Equate them and solve for n. That's all it is. Okay. So let me write. Step 1. Calculate common ratio using r equal to t2 by t1. So you got to do this for both the series. Okay, for the series 1 and series 2. Then calculate the nth term using Tn equal to a into r to the power of n minus 1. So that is equal to, in this case, what is the value of a for the first series? 162. And what is the r? I'm just, we'll do it mentally, but when you have to do it, you'll have to do it very clearly. That is, it is 1 by 3. Okay. So what it means is the nth term is 162a into r to the power of n minus 1. So this is the nth term for the first series. Similarly, do that for the second series. A is 2 by 81 and r is 3. So the nth term is 2 by 81 into 3 to the power of n minus 1. Okay. Now it's given that these two are same. The nth term of the series 1 and series 2 are same, which means 162 into 1 by 3 to the power of n minus 1 can be equated to this. So once you equate it, you will have only one variable, which is n, and that can be obtained by solving that equation. Okay, so equate 1 and 2, simplify and calculate n. Okay, so that's how this problem is to be done. So now pause the video and try to work this problem on your own, and after working, come back and check you're working against our solution. Okay, so the solution, GP for the first series is here. The information is that a is 162, t2 is 54, and for the second series, a is 2 by 81 and t2 is 2 by 27. Okay, so for the first series, we are calculating the t2 by t1, r. Okay, so r is t2 by t1, so that's equal to 54 by 162. T2 is 54 and a is 162. So 54 by 162, that is 1 by 3. 54 goes 3 times, so it's 1 by 3. And substitute the value of a and r in this equation. Tn equal to a to the power of a into r to the power of n minus 1. So you'll get Tn equal to a is 162 and r is 1 by 3. 62 into 1 by 3 to the power of n minus 1. Okay, this is equation 1. Then for the second GP, okay, the second GP is a is 2 by 81 and r is 2 by t2 is 2 by 27, correct? So t by 2 by 27 divided by A. A is, okay, we have written it here. So divided by 2 by 81. So this will become 2 by 27 into 81 by 2. So this 2 and 2 will get cancelled. 27 will go 3 times. So R equal to 3. Okay. So substitute the values of A, R in the same equation. Tn equal to A into R to the power of n minus 1. So what will we get? We will get Tn equal to A is 2 by 81. R is 3 for the second series. So we will get 2 by 81 into 3 to the power of n minus 1. But we know the nth term Tn of both series are equal. So we will have to equate the RHS of 1 and 2. Okay, what is, let's go back to the equation. So RHS of equation 1 is 162 into 1 by 3 to the power of n minus 1. Okay, so 162 into 1 by 3 to the power of n minus 1 equal to 2 by 81 into 3 to the power of n minus 1. Now you see you have 3 here, 3 here. So keep 3 together and put all the other numbers to one side. So this will become 162 into 81 divided by 2. Okay, collect all the numbers other than 3 will be equal to 3 to the power of n minus 1. This is 3 to the power of n minus 1 in the denominator. So when it goes to the other side, it comes in the numerator. Okay, this 2 will go 81. So on the left side, you'll get 81 to 81. And on the right hand side, you'll get 3 to the power of n minus 1 into 3 to the power of n minus 1. You know a to the power of m into a to the power of n is a to the power of m plus n. So you'll get 3 to the power of n minus 1 plus n minus 1, that is 2n minus 2. And 81 is what? It is 3 to the power of 4. This 81 is again 3 to the power of 4. So again applying the same principle, a to the power of m into a to the power of n equal to a to the power of m plus n. So this will become 3 to the power of 4 plus 4. So you'll get 3 to the power of 8. Okay. So 3 to the power of 8 will be 3 to the power of 2n minus 2, or 8 will be, or 2 to the power of n minus 2 will be 8. Okay, whenever two exponents are equal and if their bases are equal, their powers will be equal. So 2n minus 2 will be 8, or 2n will be 8 plus 2, 10, which means n will be equal to 10 by 2, n will be equal to 5. So it's a fifth term of both series, of the two series are equal. You got it? Now please check your working against this solution. If there is any error, please make suitable correction. If you have not understood the concept, please review the discussion part of the video and try to work it out one more time. Thank you for watching this video.